C/CD. Azure DevOps. GitHub Actions. Jenkins. 1. What are the key components of a C/CD pipeline? Answer. A C/CD pipeline typically consists of the following stages. Source code management, SCM. Code is stored in a version control system like GitHub, GitLab, or Azure repos. Build. Code is compiled and dependencies are installed. Unit testing. Automated tests are run to verify code correctness. Code analysis. Tools like SonarQube check for code quality and security vulnerabilities. Artifact packaging. The application is packaged as a Docker image, jar, or zip file. Deployment. The package is deployed to development, staging, or production environments. Monitoring and logging. Tools like Prometheus, Grafana, and Azure Monitor track application performance. 2. How do you secure secrets in a C/CD pipeline? Answer. To secure secrets in a C/CD pipeline. Azure DevOps. Use Azure Key Vault and Pipeline Secrets. GitHub Actions. Store secrets in GitHub Secrets and reference them in workflows. Jenkins. Use the Credentials plugin or integrate with HashiCorp Vault. Best practices. Do not hard code secrets in pipeline scripts. Encrypt sensitive data before storing. Implement role-based access control, RBAC, for pipelines. 3. How do you implement rollback in a C/CD pipeline? Answer. Rollback strategies include versioned artifacts. Maintain previous versions of applications, and deploy the last stable version if an issue arises. Blue-green deployment. Deploy the new version to a separate environment, and switch traffic if stable. Canary deployment. Gradually release changes to a small set of users before full rollout. Feature flags. Control feature releases dynamically without rolling back the entire deployment. Azure Cloud and Infrastructure Management. 4. How do you scale an application in Azure Kubernetes Service, AKS? Answer. Scaling in AKS can be done in multiple ways. Horizontal Pod Autoscaler, HPA. Scales the number of pods based on CPU/memory usage. Cluster Autoscaler. Adjusts the number of nodes dynamically. Manually scaling. Use kubectl scale deployment. Name replicas equals 5. Resource requests and limits. Set pod CPU/memory limits to optimize resource usage. 5. What are Azure Application Gateway and its benefits? Answer. Azure Application Gateway is a Layer 7 load balancer that provides SSL termination, offloads SSL encryption/decryption. Web Application Firewall, WAF. Protects against common web attacks. Path-based routing. Routes traffic based on the request path, for example, API versus /static. Autoscaling. Automatically adjusts backend instances based on demand. Monitoring and logging. 6. What are the key metrics to monitor in a C/CD pipeline? Answer. Build success rate, percentage of successful builds. Deployment frequency, how often deployments occur. Change failure rate, number of failed deployments. Mean time to recovery, MTTR. How fast issues are resolved. Pipeline execution time, how long builds take to complete. 7. How do you set up centralized logging for Azure Kubernetes Service? Answer. Enable Azure Monitor and Log Analytics. Integrate AKS logs with Azure Monitor. Use Fluent/FluentBit. Collect and forward logs to a centralized location. Integrate with ELK Stack. Send logs to Elasticsearch. Visualize in Kibana. Use Prometheus and Grafana. Collect and analyze metrics. Linux administration and security. 8. How do you troubleshoot high CPU usage on a Linux server? Answer. Check CPU usage. Run top or top. Identify high CPU processes. Run ps sort equals % CPU head -10. Analyze load average. Use uptime or cat/proc/loadavg. Investigate logs. Check /var/log/syslog or application logs. Optimize processes. Restart or optimize high CPU consuming services. 9. How do you harden a Linux server? Answer. Disable root login. Edit /etc/ssh/sshd_config to set permit root login no. Use SSH keys instead of passwords. Enable a firewall. Use UFU or iptables to block unnecessary ports. Regularly update packages. Run apt update and apt upgrade. Install fail to ban. Prevent brute force attacks on SSH. Monitor logs. Use journal-z and logwatch. 10. What is the difference between systemd and init in Linux? Answer. Init. Older process manager, sys vneat, upstart. Starts services sequentially. Systemd. Modern service manager. Starts services in parallel, supports logging, journal and dependency management.